Bismillahirrahmanirrahim. Now we're going to complete our technique integration. The second technique we already took the integration by substitution. The second technique now we're going to discuss with others with us is the integration by parts. This technique is useful in some ways that we can't integrate function. We maybe face a problem in this point. So we're going to choose this technique as we will discuss how to get this technique integration by part. Now we all just remember you the product rule in the differentiation. If we have f and g are differentiable functions, so d by dx f g, so we're going to satisfy the product rule, which will be f integration second function g prime plus g times time f prime. So we can integrate both sides with respect to x as like this. So f g equal integration f g prime plus integration g f prime. Okay, so we can solve for g f prime will be fg minus integration f g prime. This will be our rule in integration by part. We're going to choose a function g and the other function f prime. After that, we're going to solve for this rule will satisfy by this point. So our rule will choose u equal and dv would be equal. After that, we're going to derivative u, we will find du, and we will get integration for dv will be v. Okay, our integration will be uv, as we say that fg, minus integration v du. Okay, we're going to take an example for this to satisfy the point what we said now. This other rule proof for this. This our rule now. Integration u dv equal uv minus v du. Now, how to choose u and how to choose dv is very important point. U differentiates to 0 usually, and the dv is easy to integrate. The integration by parts formula is a product rule for integration, so you must know this point very well. Is a product rule for integration. Now, what's the meaning of Libet? Libet, what the meaning is how to choose the function u. We will choose the function u begin with L. What the meaning of L? L meaning the logarithm. If we have find in the function logarithm, we choose u. With this logarithm. If we don't find, we can use inverse. You have inverse, we should use u equal the inverse trig. After that, polynomial like x squared, x power 4, and so on. We choose u by this point, and dv the other function, as we will see in the next example. After that, e meaning exponential, t meaning trig. Okay. Now this question integration x cosine x, so we can't integrate this function. So we discuss how to use integration by part by this problem. Now we will choose u. We have Libet, as we said before. First, we have logarithm. We don't have logarithm here. Second, inverse. We don't have inverse. P, polynomial. Yes, we have polynomial here is x. So u equal x. And dv is the other, equal cosine x dx. So we will get du will be dx. We'll integrate cosine will be sine x. Our integration will be uv minus integration v du. So we will times and minus this integration x sine x minus integration sine x dx. So it's easy now to get this integration, right? X sine x minus integration sine will be negative cosine. We have here negative cosine x plus c, negative and negative equal positive. This is the final formula for our integration. Okay, this is how to apply the technique of integration by part in this point. Okay. We are complete our discussion now. As you see, this polynomial factor. So we will choose u equal x and dv equal cosine x dx. After that, we will get the derivative, first derivative for u will be du, and the other side will be dx. And also we're going to get the integration of dv equal cosine x, which will be sine x, v equals s. I'm going to use our formula here to get this uv minus v du. So the result will be, as you see now, x sine x minus integration sine x dx. So the result will be x sine x, and the integration of sine will be negative cosine, will be negative times negative equal positive, equal cosine x plus c. This is our solution for our integration above, example 1. We're going to do the second example, which be ln x dx. So we can face a difficult to get this integration. So we're using a technique that we said now, integration by part. Okay. Now we want to use Leibniz here. L meaning logarithm. So we have ln x. So we'll choose u with ln x, and dv will be dx. Yes, logarithmic factor u equal ln x and dv equal dx. So du, the derivative of ln equal 1 over x, the derivative inside the ln, so will be 1 over x dx, and the integration of dv will be v equal x. And going to satisfy the rule, our rule for part, integration u dv equal uv minus integration v du. Uv, that meaning u time ln x times x, or x times ln x, minus integration x times 1 over x will be 1. So it's easy now to integrate it. So the result will be x minus x plus c. Okay. The second example, will be this point. Now we have integration x squared ex dx. We will choose, as we said now, our Leibniz. We can, if there is another maybe acronym for this, maybe we can choose late. Late, the same as we first logarithm, after that algebraic or polynomial, trig, and exponential. So we will choose now u equal algebraic now x squared. After that dv will be ex, e power x dx. Okay. After that, we're going to get the first derivative for u will be du equal to x dx. and we get integration for dv with the same of e power x is the same e power x. So we're going to satisfy our rule uv minus v integration v dv du. So x squared minus ex minus integration e power x to time to x. We have now a problem. Now this is difficult to get integrate for this function. So we're going to satisfy the part the technique by integration by part again for this point. This point. Still product. So we need to use integration by parts again in this. So we would choose u equal x and dv equal e power x dx and get the same as we say get before, du equal dx and dv equal the same e power x, and going to satisfy our rule x squared the same minus 2 the common time x time e power x minus integration e power x dx, and this now is going to be easier than before, so the result will be e power x. So the final answer will be like this: x squared e power x minus 2x e power x plus 2 e power x plus c. You can choose e power x as a common factor and we write again. It's okay, it's as you want to make a simplification for this a final answer. We complete our examples as you see as a power x cosine x. I would like you to get this integration and give me the answer. I'll give you a while to get your try in this question. Okay, I hear something. Someone of you maybe can answer this question. So we will choose u equal what? Yes, that's right. We're going to choose as our rule u equal e power x exponential and dv will be cosine x dx. Okay, now that we're going to apply what we discussed before. Yes, and our result will be e power x sine x minus integration e power x sine x. So we find something. What find e power x sine x again. It's difficult to get integration with this point. So what we will do? We maybe again choose the integration for u equal e power x and dv sine x as we make before, and going to see what we will see. So we get the integration here negative cosine e power x e power x cosine x. So it's again another integration. So what we will do now? We have now e power x cosine x. So it's difficult now. We could repeat it integration, but this is the same of this. Look now, if I have I and this negative I will be 2i, so you should know this point correctly. You will find yes here and get this other side with positive sign. So the result will be 2 integration e power x cosine x equal the same. We have so equal half. Yes, so equal half plus c. This is our integration. This is very tricky question. Now should take care of this point. Don't make a problem if you have the same integration. We should repeat it until like this. So it's one of the tricky question maybe you face in the exam. Okay. This, as we say now, this is called solving for a known integral. It works when both factors integrate and differentiate forever. This happens as you see that when both factors integrate and differentiate forever. Okay. You have now shortcut with meaning tabular integration. What the meaning of tabular integration that we will see now? Tabular integration works for integral for the form fx times g of x dx, and we can find differentiate to 0 in several steps. We have like integration like algebraic or polynomial function x power 4 it will be x power 3 x power 2 x and 0 this and g of x in the form repeated or repeatedly, like sine x will the integration will be negative cosine, and there will be sine, and will be and like this, or e power x integrated will be e power x the same. Don't repeat it repeatedly. So this is called tabular integration. Like here, e power x now we see e power x. We will choose u equal x square and dv e power x dx, and now we'll make du will be 2x and v the same e power x will be our integration. We'll see I x square e power x minus integration of minus 2 here x e power x dx. So we will take this again. We choose u equal x and dv equal e power x dx. So du equals 1 and v equal the same e power x dx. Our integration will be here x square e power x minus 2 times x e power x minus integration e power x. Now we're going to find, we can find e power x the same e power x. This will be our point of view. So we're going to see how, if we have tabular integration, how we will make it, or we can choose it. This technique also, it's very easy. Here f of x and derivative, and here g of x integral. Here f of derivative x square, we'll put x square, right? We integrate to be 2x will be integrate to be 2, integrate to be 0, and here e power x integrate same, right? The e power x integrate e power x integrate e power x integrate e power x. Okay, so the result will be like as we see, positive, negative, positive, and integration x square e power x will be like this, x square e power x, right? And negative 2x e power x and positive 2 e power x plus c. Okay, this will be the technique of tabular integration. If we find like this, we can make this rule. It will be easier for us to make it for us. Okay, the same answer we get before with our technique, and is easier and quicker to do with tabular integration. Look how to find this tabular integration by this point. Can it satisfy or not? Yes, we can. We'll make here function with the differentiation and f, and here g and with integration. Here x power 3, here sine x. We repeat integration. Here x cube will be 3, x power 2 will be 6, x will be 6 will be 0. Here plus minus plus minus. Sine x integrating will be negative cosine. Negative cosine integrated will be negative sine. Derivative will be cosine. Derivative will be sign. Our integration would be here x cube negative x cube cosine x plus 3 x square sin x plus 6x cosine x minus 6 sin x plus c. This will be our result for this. This is very easy to do by tabular integration to make like this formula. Okay, do you see in our presentation would be in our slideshow would be the steps as we discuss manually with you to be more understand for this for this rule. This is our presentation show to make sure that we are going in the right way. Okay. Now we are finished our lesson in integration by part by this presentation.